Thanks guys for coming to see my talk on building automation. This talk is really meant to introduce you to probably a different type of control systems that maybe some of you have worked with already or have been exposed to, that are a little outside of the generic industrial control systems that have been under discussion since Stuxnet. Very short introduction about myself. So most noteworthy elements from my past. I was the lead incident handler for Stuxnet back then when it was discovered in 2010. That was mainly also the reason why I created the dedicated computer emergency response team for Siemens products. I led this for 2 other years, and these days I run my own ICS cybersecurity consultancy in Austria. I'm a professor at 2 universities where I basically teach ICS security and pen testing. I help out at the SANS Institute for teaching ICS courses, and I'm also conference chair for an academic cybersecurity conference focused on ICS. So, first of all, short disclaimer, really important, hacking building automation systems can have serious effects on your health. So I highly recommend not to hack building automation control systems without authorizations because dangerous things can happen. Also not if you're unsure what you're actually doing, like system-wise and controller-wise. You'll see what I mean when we go into the next slides. So, as I said, we're normally doing regular industrial control system security. How did we end up working on building automation control systems? Answer is because we had to. You see, our office is located like on one of the top floors, and we have an automated sun shading or sun blind systems. So the problem that we have there is those shading systems, those blind systems are connected to a wind sensor, and the issue is that this wind sensor is really sensitive. So what happens is when somebody literally farts in the second next building, the sun blinds go up and sort of we could not work anymore, we get blinded. And that's how we decided we really got to look at building automation control. And from there on, sort of we really expanded. So what is building automation control system actually about? So as most of you probably haven't been exposed to those systems, let's discuss the major use cases. The most common use case, I guess, these days is HVAC, so controlling heating, ventilation, and air conditioning. So especially in a venue like this one, most probably you would not have like direct wiring from the temperature sensor to a controller anymore, but maybe some type of bus system. So there would be some type of network packet being sent from the temperature sensor to the controller. Controller would read its logic, okay, what's the target temperature, and then send a command or another bus probably to the actuator to either turn on the heating or the air conditioning depending on its programming. Second area is lighting. So probably if you've noticed that you see a decline in like classical light switches, they're being more and more replaced by presence or motion detectors, which is the case in order to save energy. So you don't just flip switches anymore. Depending on if somebody is in the room, the system would decide whether to turn on the light or not, and maybe based also on daytime, of course. Third common application area of building control systems is just energy management as such. So, of course, it's possible to switch on specific devices at a specific point in time. So maybe when there's cheap energy available via building automation control, you could switch on specific devices which consume a lot of energy, like a washing machine or anything similar. And the last, and I think one of the most interesting application areas of building automation control is physical access control. So instead of having like a physical key through a building automation controller, you would be able to lock and unlock doors and also go into CCTV systems. So this is really a very powerful set of possibilities you get with building automation controller. So, as we know, with great power that we have with building automation controllers, there comes great responsibility. So thereby, we also decided to look into the actual state of security functions. And that's what I'm going to show on the next slide, which really summarizes the state of native security functions in building automation. I'm really glad we talked about it, right? That's not a mistake, by the way. So the thing I really want to point out here is that many building automation control protocols and technologies that we use today do miss very critical security functions. To elaborate a little bit on this, if it's possible for me to connect to a building automation control network, and I know which protocol is being spoken on this network, I can just set any command I want as long as it is sort of protocol conformant, and the device that I target, either if it's the controller or any type of sensor, will actually accept my command and do whatever I want from it. Because, for instance, there is no like embedded authentication, maybe cryptographically supported authentication in those protocols. Why? Because those protocols were designed maybe in the late 19th, early 2000s, where there still was the belief that those systems are closed networks, bus networks, which are not really interconnected, maybe not really routable networks on the way to the building automation control network, and therefore the threat model was a different thing. Same issue, of course, leads to replay and spoofing, so you can just capture existing network traffic and then replay it at a later point in time. Some of the protocols that you will see in building automation control are actually UDP based, so replaying them is even easier because you do not need to go for the TCP three-way handshake. So many of them are susceptible to replaying and spoofing. We did a number of assessments since then, and we also found sort of, outdated and legacy software. Why is that the case? If you understand how those systems are being created, it's sort of they are practically part of the building. So at some point, a property management company decides we need to have a new building. So construction starts, and at some point, electrical engineers will come, do the cabling, put in the actual building automation controllers, and also do the programming. And from that point in time, it sort of stays pretty much the same for the next 5, 10, 15 years. Why? Because those systems are pretty much part of the building itself. It's not like in the IT world where you rip and replace your systems every 3 to 5 years. And of course, those systems are quite robust and purpose-built from the physical side, but we found out if you look at them from the network side, they are definitely more fragile. In order to give you an idea what attack scenarios might be out there, so what an attacker might actually go for, I'm going to present at least one attack scenario that we are not looking forward to, so more like a blueprint. So one scenario in building automation control could actually mean you would try to go for a sort of targeted attack in the sense of a physical compromise. Enter a building, maybe some type of public building. You have to find the appropriate entry point to the building automation control system, and that's pretty straightforward. Some of them are quite easy to reach. For instance, those motion and presence detectors, they're usually easy to reach because they're being placed sort of at that type of level. So you can just approach one, pull it off, and then try to connect to the actual building automation bus. So this is an example of a KNX bus system, so 2-wire bus that we were using there. That's pretty much it. Rip out the plug, connect 2 wires, connect that to a KNX USB dongle, and from that point in time, you're pretty much in the building automation control system and can do whatever you want. What is it that you might want to do? Well, if you think about a scenario that there is maybe a contract hacker being hired from a competing property management company, a building where there's nice condominiums, Probably he could enter the building, connect to the network, and then just trigger random alarms like fire alarms, gas alarms, which throw people out of their beds at random times in the morning. For instance, through spoof messages, fake sensor readings, anything's possible here from a technology perspective. And if you do this quite often, most probably people will start to leave this building before they could not sleep anymore. So if you combine this type of attack, maybe with a rogue device, something like a Raspberry Pi on a battery pack with 3G, as I said already, it's possible to send spoofed messages. So at one point in time, I would spoof maybe a temperature sensor. At another point, I would spoof maybe a gas leak sensor. It would be really, really difficult for the actual operator of the building to find out what is the exact reason why those alarms are actually happening. So as this is a security conference, I also would like to give you a little bit of information on how to approach those types of systems more from the security perspective. So also to give you ideas what type of penetration testing or security testing tools exist out there already if you would like to explore maybe your own home automation system. If you're into pen testing, you know the very first step is always about information gathering, learning about the actual target. The good news is, if for our good old friend Nmap, there is already a significant amount of scripts out there which map building automation systems. So if you're going, for instance, for KNXNet IP, which is a protocol that is highly or that is widely used throughout Europe and also Asia, that type of plugin comes already with Nmap out of the box. If you are more into BACnet IP, which is a standard that is widely used, especially in the United States and also a little bit in Europe, you would need to tap into Project Redpoint created by Digital Bond to get the actual fingerprinting script for Nmap down. There's another tool called HVAC Scanner. It looks for specific building automation control devices from Honeywell and also Tridium Niagara controllers. It's not working by tapping into the real building automation control protocols, but instead looking at fingerprints of the web servers of those devices, so sort of the HMI type of systems. And finally, some of the more common professional security scanners like Nessus also have like rudimentary implementations of fingerprinting plugins for detecting building automation systems. But only a small fraction actually is covered of the protocols out there. So if you're into pen testing and you would like to explore or actually abuse to a certain sense a building automation system, you definitely would need to understand at some point a little bit more about the actual protocol. So we're going to talk about two protocols here. One is KNX, the other one is BACnet, which I'll cover later. So KNX is a good example because it comes in different forms, in types of, in the sense of physical media that it supports. There's KNX Twisted Pair. Remember the photo I had before, the 2-wire bus. There's KNX RF radio frequency, and of course, luckily for us, there's also KNXNet IP, which defines how KNX network protocol should be transmitted over a regular IP network. And of course, there's also protocol converters out there which allow you to have a KNXNet IP gateway in an IP network, and behind that, the regular KNX bus. If you look at it from a service or functionality perspective, you would have something like core services, which within KNXNet IP for locating and identifying those types of devices as such. You would have another group of services for actual configuration and device management. Then there's two types of, I would say, service groups for communication, one for tunneling, one for routing, and finally the last group of services is actually there for remote diagnostic as well. So let's explore a little more the actual tooling options that you have out there. You know, in my company back home, we have a saying, there is no better hacking tool for industrial control systems than the original engineering software, so like the programming software. And this is an example of that as well. So what you see here is screenshots from the so-called ETS, the engineering tool software that is being put out by the KNX associations to program those types of devices. So the original controls engineers and electrical engineers which built those systems used this software to program a specific building automation controller. But there are certain functionalities in there which I'd like to point out, which are also interesting for pen testing and security purposes. The first one is on the left side, so-called group monitoring. Group monitoring is really the equivalent of sort of packet sniffing, like you would do with Wireshark. But here we do not have an Ethernet or even IP-based network. It's like a two-wire bus. But the principle is the same. Basically, I'm sniffing the two-wire bus and I'm building up a list of packets that I see here. You see here different source addresses, which for KNX may be something like 1.14.12. And on the right side, you would see destination addresses. And if I look there, if I look into that for maybe several minutes, I will see probably lots and lots of addresses on the source side, but only few addresses on the destination sides. And the few addresses on the destination side are, of course, the actual controllers where the different sensors report to. So that's the equivalent of passive information gathering in a KNX network. I would like to point out one functionality which I found quite interesting. They intentionally built in also the function called replay telegrams. So most probably that was included for debugging the building automation control system, but for security purposes, of course, this could be a valid attack tool. On the right side, you see the equivalent of an active information gathering attempt, a so-called line scan. So with that, I can do pretty much the same I would do maybe in a Class C network, so scan the available address space and see which addresses are already taken. So pretty straightforward, and you can download the ETS just from the KNX Association's website. If you're not that into using graphical user interface tools, if you're more into command line tools, this next tool I'd like to recommend is called KNX Map, created by a bunch of German security researchers. It has the same functionalities for passive and active information gathering. It also has a little more functionality, like allows you to brute force the so-called bus coupling unit key, which is just a 32-bit key, so it's really feasible to brute force it for specific configurations. If you actually would like to change the behavior of the building automation controller, you would want to make use of group messaging or APCI functions. So, for instance, sending something like turn off everything, like a wildcard. That's what it would go for with group messaging. And APCI functions in principle mean something like reading or writing memory of a specific controller, restarting a device, whatever you want to do with one specific type of device. Second protocol that I'd like to present is BACnet IP, so Building Automation Control Network. It's another, what I would call manufacturer-independent standard. So it defines for each device a standard set of objects, and each object has properties and services. Some of those services are mandatory, like the read property service. And again, for your convenience, we've sort of grouped the BACnet IP service into different logical groups. Alarm and event services for actually finding out if what's going on within a BACnet network. There's also file access and virtual terminal services. So I'm not talking about FTP or Telnet here, but really more about the BACnet equivalent of those functions. So you really see BACnet is sort of a complex protocol, and it's really powerful in the sense that it allows file access and also terminal services. Manipulating objects is possible, of course, reading, writing, modifying properties, and there's special messages for remote device management. There's one specific function that we really love, and it's called BACnet IP Broadcast Management Devices, BBMD, and Foreign Device Registration. That function within BACnet is really excellent for pen testing because it actually allows you to breach a building automation control network from the inside, although you cannot really reach it from the outside. What do I mean by this? Imagine there is a scenario where there's a BACnet device in an internal private network that for maintenance purposes, for service purposes, also has maybe something like a port forwarding from the internet activated. So the BACnet IP port would be reachable from the internet by port forwarding. If this device supports this BBMND function, what I would be able to do is I could come from the outside, register through this foreign device registration function, and from that point in time on, I would be able to talk to all the internal other BACnet systems as if I was on the internal network side. So even if you did your network security right, even if there's no routing available, you would be able to compromise the building automation control network through that function. Is that an issue, a practical issue? Unfortunately, yes. We have found nearly 3,000 systems, BACnet systems in the US alone, which expose this dangerous BBMD function. If you look at it more on a global perspective, it's like 15,000 devices out there which support this function. And you see it down here, it's a good example. So I intentionally blacked out the full public IP address, something ending with .124. 47808 is the actual BACnet port. If I would connect to the system and use the BBMD function, I would be able to talk to 192.168.3.2, although they are not reachable from the internet through routing. So pretty dangerous. And by the way, on this screenshot, you also see that it's not only smart home or home automation systems that are on the internet with BACnet. The topmost screenshot or topmost system here on Shodan is from some type of city parkway access. So there's different types of systems that you actually see that are connected through BACnet. As we did with KNX, if you want to actually talk to specific BACnet devices or abuse specific protocol functions, maybe in a penetration test for one of your clients. Again, there's different functions you should know, again, in different groups. For information gathering, you most probably would use something like read property. I mentioned the read foreign device table. If you call the initial routing table service, you would get a list of the device's routing table itself back. If you are more into spoofing, again, register foreign device or just IAM or I'm router to network functions are the thing to go for. If you would like to create something like a denial of service, could just do this by a large number of whois requests or maybe signaling that a specific network cannot be reached through router busy to network services. Maybe you could try to create a routing loop through the initialized routing table or just send devices constantly into reboots through the reinitialize device command. That's what I have on the next slide. And therefore declining regular service to all the other clients. So here on the top left, we have our alleged building automation controller server. On the right side, we have our Mr. Evil, which is technically just another BACnet client which requests our server to reinitialize constantly. So basically we're sending a reinitialize command every 10 seconds, which means that the other legit clients cannot connect or cannot do anything with it anymore. With our tests, we found out that some of the devices out there do require passwords or may require passwords depending on vendor to actually call this function or to execute this function. Well, guess what? You will find the password in most cases in the vendor's actual manual. In this case, the password was Jesus. So thanks, Jesus, for helping us. I also mentioned before that those systems tend to be quite robust on the physical side, but not so robust on the network side. So what we created is just a very, very rudimentary backnet IP fuzzer using SCAPI. So what we did, the very first layer we tapped into was NPDU and APDU fuzzing. And you see down there, within the very first seconds, we received already a number of segmentation faults. So this is a screenshot from, I think, the most widely used open source implementation of backnet available on SourceForge. I really hope that there's not too many devices out there which rely on this protocol stack in that state because of the stability issues. As this vulnerability, at least today, is still a 0-day. It hasn't been fixed yet at this point. So as you've seen, building automation control is pretty powerful, pretty interesting, and it's quite widely deployed. Question is, how can we fix this? How can we improve the overall situations? So, in my opinion, this is quite typical. It's on the one hand a technology issue, but on the second hand, it's also a people and knowledge issue. What do I mean by this? So the technology issue really is that at least the current generation of building automation control systems still lacks this security by design or secure by design approach that we've had in general IT for 15 years now, that has started in generic industrial control systems, I would say to a fair amount, thanks to Stuxnet, but at least is not the case, at least for the building automation control sector. Why do I also claim that this is part of a knowledge problem or people problem? Well, the industry associations behind those technologies, like ASHRAE or the KNX Association responsible for those protocols, at some point they recognized already that there is maybe security issues out there that need to be addressed. So they put out guidelines and recommendations how to, counter those risks, how to mitigate at least some of them, how to retrofit security, because you cannot entirely change it at this point in time at least. If the guidelines actually would have been or would be adhered to, then most probably we wouldn't see 3,000 systems in the US that expose this BBMND function, or 15,000 worldwide. We also did I would say, small survey among building automation integrators, so those guys responsible for creating and building those systems. We did this in Europe for KNX-based system operators and integrators, and I think just a very, very small fraction actually had the idea that what they are doing has a dedicated security responsibility. Why? Because the majority of people who creates those building automation control systems are electrical engineers, they're automation engineers, they're controls engineers, and not security people. However, the world, of course, from a technology perspective has changed. There is KNXNet IP, there is BACnet IP, and therefore security should be addressed to a certain extent. So from a general perspective, there is holistic measures, something like applying a proposed network architectures, trying to reduce external access points, so it's not as easy to just pull down maybe a presence detector and connecting it. Maybe also increase monitoring, so that's like holistic measures. And of course, for each protocol, there's different possibilities out there to deploy security proxies or just restrict communication paths. Maybe something like line address filters, for instance, with the KNX protocol. Is that everything? Unfortunately, or fortunately not. So what we really did is we looked at two specific protocols, KNXNet IP and BACnet IP, because those systems are really widely deployed throughout different regions in the world. But there's many other technologies out there or protocols within building automation control systems that are definitely worthwhile to be explored. So I really hope you got an impression and you got an interest into looking into building automation control systems. if you have any questions, that's the end of my presentation. I'm glad you were here. And I really would like to invite you to come over to the ICS village. We have just great systems over there. If you have any questions, I'll be happy to answer them just in the second next room over there. Thank you.